Determine all values of c that satisfy the conclusion of the mean value theorem for the function f of x equals 4 plus 6x minus x squared on the interval 2 included to 8 included. The first thing to do is to determine whether the two conditions are met for the mean value theorem to apply. The first condition, the function f of x equals 4 plus 6x minus x squared has to be continuous on the closed interval given. 4 plus 6x minus x squared is a polynomial. And a polynomial is continuous on any interval. So it'll be continuous on the closed interval 2 to 8. Closed means it includes both ends, square brackets on both ends. So condition 1 holds true. Condition 2, the derivative. F prime of x. First term constant, derivative 0. Second term constant times x, derivative is the constant. Third term power rule, bring down the power, multiply with the negative 1, subtract 1 from the power. The derivative has to be continuous. It's called differentiable on the open interval. Well, the derivative, 6 minus 2x, is also a polynomial and is continuous on any interval. It's therefore continuous. It's called differentiable for the continuity of the derivative on the open interval. It's always the open interval because the function is never differentiable on its endpoints. So this will always be the open interval, not including either end, indicated by round brackets on either end. Condition 2 holds true. Since both conditions hold true, the conclusion of the mean value theorem does apply. And the conclusion is that f prime of c, the slope of the tangent line, will equal f of b minus f of a over b minus a, the slope of the secant line connecting the endpoints, for at least one c, perhaps more, in the open interval of 2 to 8. In this problem, the interval 2 to 8 tells us that the a value, the left endpoint, is a 2, and the b value, the right endpoint, is an 8. So this will equal f of 8 minus f of 2 divided by 8 minus 2. F prime of c is evaluated by plugging c into f prime of x. So the left side will be 6 minus 2c. The right side will be f of 8 minus f of 2, determined by plugging those into the f of x. F of 8, 4 plus 6 times 8 minus 8 squared, minus f of 2, 4 plus 6 times 2 minus 2 squared, all divided by 8 minus 2. 4 plus 6 times 8 is a 48, minus 8 squared is a 64, minus 4 plus 6 times 2 is a 12, minus 2 squared is a 4, all divided by 8 minus 2, which is 6. 4 plus 48 is a 52, and then minus 64 is a negative 12. And then minus 4 plus 12, 16 minus 4 is a 12. All over 6. Negative 12 minus 12 is negative 24 divided by 6. So 6 minus 2c will equal to negative 24 divided by 6, which is a negative 4. Let's subtract 6 from both sides. Negative 2c equals to negative 10, and then divide both sides by a negative 2, and that'll give c equals to a 5. We keep only those c's that are in the interval up here. We're guaranteed at least 1, perhaps more. We ended up with exactly 1. C equals 5. that satisfies the conclusion of the mean value theorem.